All right, here is the Unit 3 practice test key. Let's fix our pen. Okay, this first question just asks you to name them. I'm going to go through the easy ones. This is cubic. That is f of x equals x cubed. This one is quadratic. F of x equals x squared. This one is the cube root. So f of x equals cube root of x. This one right here is a square root. Now these two right here are one's exponential and one's a logarithm. This one up top is exponential. And you can tell which one's which by their asymptotes. So if you remember, asymptotes are like this wall where the graph doesn't make it past. So this guy has a wall right here, which is horizontal, and that makes it exponential. So the base function is something b to the x. This one is a logarithm, and it's the inverse of it. So your line that it doesn't cross now is this vertical line. And the basic function looks like this. All right, moving on to these examples. Now, you were supposed to draw a graph of it and identify all these pieces. Okay, so there's my beautiful, beautiful graph. It is so pretty. Let's talk transformations first of all. So this thing has been moved one to the right, and it's been horizontally shrunk by 1/2. So right here is the right. I know it's right because it's inside, and we're subtracting. So that makes it a horizontal shift, right 1. Technically, if you looked at the graph and compared it to the transformation, it actually only moved right 1/2, and that's because of this guy right here. So this guy is multiplying inside, which means it's a horizontal, either a stretch or shrink. Now remember, horizontal is always backwards. So if you're multiplying by 2, you'll look at the reciprocal. The reciprocal is 1/2, which is a number less than 1, greater than 0. So you would say horizontal shrink by 1/2. Domain and range. Let's see if we graph this. If we look to the left and look at the x's and where does my graph stop? It doesn't, because it goes on forever in the y's. So on the left it's forever. On the right it's forever, right? Going on forever, going on forever. That makes it negative infinity to positive infinity. Or if you like inequalities, all real numbers. But as far as the range goes, if you were to look at a line, well, that's way too big. Sorry, totally got distracted by that. We put a line, but we're going to make it a little bitty line. Okay. So here's the line I'm going to use. It's a perfectly straight line. What are you talking about? If I'm going along the graph and I'm going down and I'm trying to make sure which y values will actually touch the graph if I make that horizontal line. And notice when we get down here to where y equals 0, I can't go past that. There's no more graph past that. So we would say that the bottom, the lowest number, is 0, comma, and then we move our graph again the red thing, and we go up as far as we can. Oops. And it turns out that we can go on forever, which means since we're going up, good Lord, it's going to infinity. Now, if the 0 is included, it's a bracket. If it's not included, it's a parentheses. It does actually, right, sorry about that, fixed it. So it does include the 0 right there. I really did fix it, don't worry. So we would put a bracket, right? It goes through that point right there, which makes it a bracket. Okay, x-intercept, it looks like it happens at 0.5 and 0, and then the y-intercept, it happens at 0, 1. I'm just pulling this information from the graph. As long as you know where to find the intercepts, it's just pulling the information off the graph. Okay, let's come back to end behavior and talk about even, odd, or neither. If a graph is even, that means if I were to cut this graph right here at the y-axis and switch sides, so flip this side over to that side and this side over to that side, turning this graph basically into something different. If I were to flip that, this half, this vertex, would now be over here. It would not be in the same spot. So it can't be even. Now, odd would be if you took a pin in the middle of it and you turn the whole picture clockwise around the graph. If it produces the same picture, then it is an odd function. In this case, it doesn't, because then our vertex would be, or sorry, our parabola would be upside down. So in this case, it would be neither. Oops, why did you exit out, lady? Why are we still in crisscross mode? Neither. Let's talk increasing. So increasing and decreasing, this is the choo-choo, right? My graph is horrible, you guys. Why didn't you stop me? Let me try and redraw. Hold on. Okay, still not perfect, but whatever. Nobody's perfect. So we're going to look for intervals that are increasing and decreasing, and we always move from left to right. So I'm starting over here on the left side of my function, right? Let's go right here. That's my choo-choo. Riding along. Is the choo-choo going uphill or downhill? Going downhill, so that portion of the graph will be decreasing. Right here is where it stops and changes position. So this interval right over here is my decreasing interval. And then we just have to describe it. Clear out here to the end of the earth is negative infinity, comma, and then it goes up here until 0.5, which is where it changes directions. So we would say it ends at 0.5. Increasing and decreasing, they're always parentheses. Technically at this point 5, it's not doing either increasing or decreasing. So then if you continue looking at the graph, the choo-choo changes direction, and now he's going uphill. Uphill means increasing. So from 0.5 over here to positive infinity, what? My fingers keep hitting this stupid thing. So now the increasing interval is from 0.5 to infinity. 0.5. Okay, and then going right after that is the extrema, because they're related, right? Extrema is where it changes from increasing to decreasing or decreasing to increasing. And if notice here on the left side we're decreasing, flipped, turned to increasing. So we know we have either a maximum or a minimum. Looking at the graph, it's a low point, so it's going to be a minimum. And then you just give the coordinates of where it happens. Happens at 0.5, 0. All right, let's go back to end behavior. End behavior is looking at the graph and describing at the very ends of the graph. What is the graph doing? Where are the y's going? So right over here is going to be one statement that we make. And since that's on the right x-axis, right side of it, which goes to positive infinity, we would start our sentence with as x goes to positive infinity, comma, f of x goes to, now f of x is the same thing as y. So on this side of the graph, y, what is y doing? Well, it's going up here to positive infinity. So that is what your f of x is doing. Okay, the other half is when x is going out here to negative infinity land. So you would say as x goes to negative infinity, comma, then you look at what the graph is doing. Looks like the graph is going up here forever and ever. So f of x is going to positive infinity as well. All right, let's talk about this one. Okay, this is a square root. Normally it looks like this, right? Parent function. This one, though, has a negative out in front, right? Outside and a negative. That means there has been a reflection. It's out in front, so you know it's vertical, which means up to down and down to up, and that's over the x-axis. Now, it's also got this adding 2 inside. And remember, you've got your cheat sheet to help you remember these, but if it's inside, we automatically know it's horizontal. If you're adding and subtracting, that's doing some kind of shift. And we also know that inside is always backwards. So even though we're subtracting 2, which would push stuff in the negative direction, it's actually going to be a right side transformation. Horizontal shift right 2. Okay, we got to get a little graph going on over here. Okay, it's not perfect, but whatevs, right? Let's talk domain. So domain is how far left does the graph go, how far right does the graph go in terms of x. So again, if I have myself a nice little line here, that'll work. We'll make it a red one again, sure. So here's a little line. Whoops, got crooked. When I'm talking x's, domains, I'm talking left or right. So I'm going to take this little guy, I'm going to start at the graph, and I'm going to say, okay, how far left can I go before I run out of graph? Beep, beep, beep. Oh, looks like right there, that's where it stops. So that x value is how far left I can go. That's at 2. So 2. Hopefully I fixed that. So 2 would be my left number, comma, and then looking at our line again, here's our big line. Now I'm going to take and move to the right and say, when am I going to run out of graph? Beep, beep, beep. Goes on forever. So we would say that that one is infinity. Infinity is always a parentheses. The number is either parentheses or bracket, depending on what's going on at that point. Since it does go through the 0.20, we're going to put a bracket. Okay, now we're going to talk range. Range, instead of left and right, it's down and up. So here we go, caught our function. I'm moving down, going down, 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 and I'm wondering what y value would be the lowest y value. Well, if this guy goes on forever, never, never, that means if I go down here forever, never, never, I just always have to go look to the right, and there's going to be my graph. So the bottomest most point is going to be negative infinity. And then when you look at it again, and we go up this time, okay, going up the graph, looks like the graph ends right there. Right there, the value of y is 0. And again, it's included. So domain and range, that's it. You just have to say, okay, what's the last x on the left? What's the last y on the right? Or sorry, last y at the bottom, last x at the top. Okay, let's move on. So here's my graph. X-intercept is where it crosses the x-axis. That's going to be this point right here. Oops. What happened there? Weird. So at that point 2, 0, that's where it crosses the y-axis.